All right, welcome back. We are COMP301, that's Linux operating systems at Centennial, and it's in the summer semester, 2020. And we're week 10, part 1 of our broadcasts, and we're talking about sets. And later on, we're going to be talking about dynamic visualization, right? So again, we're way ahead of where we're supposed to be. Here, we're still supposed to be talking about like strings and text this week, right? And we're way past where we should be. We're way past the bottom of the course. I've given you way more than was scheduled, and the reason for this is because I'm a crazy guy, and I want to give you as much as I can. Not to make you crazy, but because my perspective, you should know what a data type is. You should know what a control statement is. You should know what strings and text files are, and you should know. We already covered lists, dictionaries, and tuples, and functions. So we've covered all this stuff. So now we're getting into some new material. I'm just pointing out where we are physically in the list of things to know, right? But before that, let's get into what's due. So if I look at the assignments, you can see that we have an assignment number 3 that's been slated to be due by next week on Friday at 11:59. I give you an assignment. Please make sure if you haven't started on this one already that you start early. It's not that long. It's only a couple of tasks that you have to do with Python. I think it's pretty straightforward to get it done. So again, even though we've gone way ahead in terms of teaching, I'm not increasing the assignment difficulty, just to be fair. Okay? So that's something that we want to kind of go over this week. So this week, again, I'm just going to make a brand new folder. So I'm going to go here in Visual Studio Code, and I'm going to make a new folder. So again, we can close our folder, and I'm going to make a new structure. So I want to get a new folder going on. One thing you can't do is, and I have a problem with this, is the drag and drop functionality that we normally get in Windows, but that's okay. So make a new folder called COMP301, and then it's M2020 lesson 10. I always like to make a new folder so that way when it comes to our work, we can separate what we've done last week from this week and so on. So open a folder. We're going to go open this one and press OK. Awesome. And what I want to start with is our main.py. Trying to start there more often. So main.py. And what we're going to do is we're going to start with sets. So we're going to make a function def sets, right, as an example. And for now, we're going to print hello. Okay. And if I was to run this, if I said something like Python, and then I said main.py, then we got nothing because we've never called sets. Okay. Hello. So again, a bit of a review of functions right there. So lots of stuff to go through. I'm probably going to cover the visualizations piece on Thursday this week. So we're probably going to get partly done here. I'm not going to kill you today, and I'm hoping to end a little earlier today to give you some time back. But basically, I want to go over sets and what the difference between sets and some of the other things are. But before we get there, before we get into what sets are, so let's do a bit of a review. So if I was going to, let's just comment this out for a second. And we have a function called sets, but who cares? So question for you guys. It works in Cinnamon, eh? Yeah, I'm a little bit, I'm definitely, does it need to be a UI, Steve? For assignment 3, what do you mean by a UI? Before we move on. I got to look at that, Steve. Let's talk after. I want to see what that means. the UI. Maybe it's wrong. Okay. Again, what I want to do is go over some basic things. So if I'm making an array, right? If I make an array called my array, how do I do that? Review. I want to see what you guys think. Put it in the chat. I want to make an array. I want to make it my array. What do I do to make it? What do I do to make an array? And this could be on a quiz as an example. If I asked you for this, well, how do I make an array in Python? I'm looking to see the chat. Yes, thank you, Anaru. So I'll even use the stuff you typed. So there we go. So array, and then if I print that out for a second, my array, then what we're going to get is something that looks like this. 1, 2, 3. Yep, my array. All right. If I wanted to create a tuple, what is the difference between an array and a tuple? How do I make a tuple? So I've done an array, and now I want to make a tuple. How do I do it? Thank you again. So, okay, and we've talked about my tuple, and then we'll just do one of these in Python. 1, 2, 3, right? So you can see it's exactly the same, all right? But now, in terms of functionality, what's the difference between an array if you were going to be asked in an interview? Someone says, okay, Python, you want to talk about an array and a tuple. Let me do one more thing. How about a dictionary? How do I make a dictionary? This is different. So we talked about arrays, tuples, and dictionaries so far. So how do I construct a dictionary? So I'll say my dict. My dictionary is equal to, how do I do it? I could use curly braces. And this is, it's like an associative array. So I could do something like Tom equals to Tom, like you're specifying. I could do something like this, right? My dictionary, right? But notice how it gives me a bit of an error, right? So yes and no. What else? How else can I do something like this? So curly brace. So this is the first way you start a dictionary, and then you go my dictionary Tom, right, is equal to Tom, right? Oh yeah, I'm getting weird keyboard mania today. Print my dict and then Tom. So I could do this, right? Where I get key value pairs, right? Tom, capital T, is indexed by Tom, lowercase t, right? But I could do it not just like this, but I could also do it inside here. I could say that Tom, right? Could I not do this? So let's say Professor Tom. And then could I not say, like, you know, age, you know, like this, like almost like a JSON data. I'm going to put a number in there, 40, and then curly brace, close the curly brace. Could I not do that? And then if I said something like print my dictionary, and then I said age, let's see what that would do. Right, 40, right? So you can do that way too. You can set up, you know, this kind of stuff with curly braces, right? So this is the way it looks, very much like, to me, JSON data, JavaScript object notation, almost the exact same. That's kind of like what a dictionary is. It gives you key, this is the key, value pairs, key value pairs, right? So that's what dictionaries do. Okay, so today we're going to learn something else. We're going to learn something called a set. But before we get there, we know that key value pairs, right, in a dictionary is an associative array, and is it ordered or unordered? If I was going to loop through a dictionary, right, and let's suppose I had another thing like, let's say I had a dictionary of colors. So I said, you know, color one is equal to red. Color 2 is equal to blue. Actually, we'll make it green just to be complete. And then color 3 is equal to green or blue. I'll be okay. RGB. And we'll say color 4 is equal to alpha, which is your alpha transparency, right? Let's just say. Let's make this bigger. And if I want to print out color 1, then we can index it with square brackets, right? Red. But if I want to loop through and print all of them in a dictionary for a tuple or an array, no problem. We know how to loop through. But what about for a dictionary? How do I create a loop for a dictionary? How do I iterate through a dictionary? How do I do that? I'm waiting for you guys to... Steve, is that a hand like you have a solution? Or Steve, you have a hand that you have a problem? First question. Okay, excellent. So what about, so what do you think, how do we do a loop? I'm asking you guys, because let's try and work through this together, guys. So I'm doing a loop. I'm looping through stuff, right? How do I loop through things? How do I do a loop? This is just review from, you know, from the last time. I'm hoping you guys can figure it out, because we're going to get more complex now. Sets are a little different, right? Well, let's try it. If I do a for loop, so if I start typing a for loop, right, and I say for whatever the target is, and this is for a list. Let's say, for example, say for every color in my dictionary. Can I do that? And my dictionary, I want to print the color value or whatever that is. Is that good? Can I do this? Can I do a for in loop, and then would it work? And I see these are the keys, right? So this is color 1, 2, 3, 4. That's the keys to the dictionary, right? So that's not really what I want. What is another way to loop through from a dictionary perspective? I want to loop through, I want to get a... Can I loop through? How about that? That's another question. Is that possible for me to iterate through a dictionary? It doesn't make sense, right? Because I'm trying to get the values. So these are the values. These are all the values, color 1, 2, 3, 4, right? And I can't do... If I go back here, I can't just do print my dictionary and then, you know, color, because color is a, well, let's see if I can. And am I going to get a key error? Oh no, I'm good, right? So that's one way to do it. I was thinking I was going to get a key error. But yeah, so Python's smart enough to figure out that what I want to do. I want to say for every color, for every key, that's what this is, for every key inside my dictionary, loop through each element, each key, and then I want to print out the value of my dictionary. So if you want to break it down a little bit, I could say that, let's just make it like this, key is equal to the color, right? And I could say value is equal to my dictionary key, right? Key value pairs. And then I can just print out the value, right? That's just what I'm doing. I just did it in one line. So this is a way of doing it, right? Same thing. And that's how you iterate. You iterate through it, but slightly different than what it is. So what's the difference between going back now, so my array and my tuple, they look the same. The only thing that's different is a square bracket and a parentheses. Here's a list, here's a tuple or a tuple. What's the difference between a list and a tuple? If you're going to be asked a question on a test, what would be the difference between one and the other? Major difference. Tuples can't be altered. Exactly. So they're immutable. And then Vaisal, you said it too. They're definitely immutable. Whereas lists, I can modify them. I can change them. I can do all kinds of stuff with them. And so we're going to see a new structure called sets. And let's see what the set structure is like too. I'm not sure why, but for whatever reason, my mouse is just not happy with me today. I'm just gonna have to go and do one of these. So this is this stuff. We're gonna work with sets now. This is just for practice. Awesome. All right. Well, if we know all that, then let's take a look at here's something else we can do. There's something called the collections module. So collections, we can import from their collection something called counter, and what I can do is I can loop through, and this could work, by the way, for dictionaries as well as sets or other collections. I can say for every word count, right? And I can look at counter items in a sorted, I can sort the object that I want. So here's text as an example. In this case, this text would be because it's in round brackets, there's a tuple, right? So two tuples. One is this one, right? Well, this is the first element. This is the second element, right? And we want to split this by declaring a new counter object, a new counter that's taking the text object and splitting it into parts. So 1, 2, 3, 4, 5, 6, 7. There's 7 words here, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 words in the second example. So for word and count in sorted returns the word, and it also returns the count, right? How many words I have in my particular object, right, as an example. Not how many times it appears, but how many words that I have, right? And this would be a way of doing it. So this is a counting function, and we might need to see this later on if we were going to use the counter object to do it. That's just a warm-up. All right, so one thing that's different about sets that's kind of similar to lists and dictionaries in some ways is that the values that are contained in sets, you can only have one. They must be unique values, right? That's the one thing about sets, okay? So one thing that they do not support, and just like dictionaries, they don't support slicing. We talked about slicing when you kind of take a look at a list and I want, let's say the last value, or I want the first value. So example, if I had a list, as an example, let's say my list, and it was a list of color values. So I had something like, in square brackets, red, green, blue, right? Let's say red, green, blue. Those are my list values. And what I said, if I want to say print my list, and I want to say colon -1, this is slicing. This idea here is slicing. So what this will produce is red and green, but we'll chop off the last part. The last part will not function anymore, right? So that's something that this will not produce. Now it's working again somehow. I love my mouse. Okay. Does that make sense? So slicing, right? And then you can slice from the other way. So I can say, well, I want to start at 1. I want to chop off the front and the back. And if I did this and tried it again, then you can see I'm only going to get green because I've sliced off the back, and I've sliced off the front and back, 1 from the left side, 1 from the right side, front and back. That's what I've done, and I'm left with something in the middle, green, slicing. Okay, so that's what slicing is. And like it says here, one thing that it will not allow us, it will now allow slicing for sets. Sets don't support slicing, and neither do dictionaries. So here's something interesting. We still use the curly brace for sets, similar to what we do with the dictionary. So this is where people get confused. They're like, wait, I have the square bracket for lists. I have the round bracket for tuples or tuples. We have the curly brace, right, when we make things like dictionaries, right? But wait, now I have the curly brace, and I can also use sets? Wait, what? Yeah. So if I had a set, and let's say we called a set of colors, so we say colors, as an example, and we say that the colors is equal to curly brace, and we said red, green, blue, red, and green, right? The really interesting thing about sets is that when I come to print colors, right, that you're gonna only get unique elements out. So that's something that's different about sets than anything else. I can have a bunch of the same things, as an example. I can generate random numbers between, like we did last day with our little random number generator, right? But I only care about unique elements, right, in a set. Okay, so that's the difference, the distinction between some of the other collection types like lists and tuples. Because lists and tuples, you can have as many combinations of the same item over and over again. And dictionaries, well, you have to have key value pairs. So as long as you have a key, you can have the same value over and over again. It doesn't matter. Can't have more than one key though. The same key, one key will just overwrite the other one, right? So you have each key is unique. Just like a key inside of a database. That's why the dictionary is kind of like a database or a map in some ways. So that's this part. Okay, so it's unique. The other thing that is also unique about sets is that they are unordered. So notice that here I said red, green, blue, red, green, and we got green, blue, red. Green, blue, red. So it didn't even come back to me alphabetical. Look, green, G would come after B, right? So if it was alphabetical, it would be like blue, green, red. But it didn't do that. It stored the values however it felt like. And this next time it stored it a different way. And if I run it again, it's going to store it a third way. Look, it doesn't return it in any particular way, is what I'm saying. Okay? So that is a weird thing. It's completely unordered. It almost makes it as if when I get something back from a set, I'm going to get some random value back, as an example. So one thing I can't do in a set is if I say something like, okay, so I want to print color 0. All right, so the first element of the color. Well, it says colors. If I do this, colors 0, I'm expecting to get red back, right? So, and it says set object is not subscriptable, right? So I can't, because it's unordered, right? It's unordered completely. I can't look at a particular subscript because it's not ordered in any specific way. There is no index for this thing, right? So that is an issue, right, when it comes to sets, right? It's not something that I can access directly. I can't sit there and go, hey, let's access that color value directly. It doesn't work like that. Okay, so that's a couple things here. So they're unordered, right? They're unique. They only return one. If you have two reds, you only get only one red back, and it returns it in whatever order it feels like at the time. If I want to get the total length, I can use a length function. I can know how many objects or elements in the set. I can figure that out, no problem. I can check if a set has a particular value by using the in or not in operator, and it'll give me a true or false. So if I said, print red, as an example, in colors, right? Then I should, if this is true, then I should get a true in. So I say red, lowercase r, it's case sensitive, then I'm going to get false, right? But if I was to change this around to an R, capital R, and I try that again, then I'm going to get true, right? So I can test to see if something's in a set. Okay, that's one thing I can do. Is red in the set of colors that I have, or purple? No, right? I can also check not in, which is basically an inverted check. So where in is, I'm getting it true if the thing is there. If I said not in, then if it was not there, I'd get positive, right? I would get true. I can iterate just like we've done with our color. For every color in colors, I can iterate through. And here you can see that we're using color.upper. Upper is converting the string to uppercase. I'm not going to go through that, but that's what you can do. So definitely iterable, right? You can go through there. I can use the built-in set function. This is kind of interesting. So I have a list with a range of 10 and another list with a range of 5, so 0 to 5. I can combine those two lists with the plus. This is the way we did it with arithmetic. And then I can make a set of numbers based on those two lists, where once I get the set, it reduces the numbers that are duplicate to unique numbers. So again, if I had my colors, let's say we'll call this colors 1, and I had another colors 2, and let's say, for example, colors 2 also included red, but had purple, violet, violet, I'll be okay, orange, and brown. Okay, so there's colors. And if I was to add these together, right? Let's say, for example, I said I want to add colors is equal to colors 1 plus colors 2, and I want to print colors. So I'm using, instead of using sets here, I'm just combining two sets together with a plus operator, right? Let's see what I get. And I get a type error. It says I can't add two sets together. So I can't add set and set. Can't do that. These two. If I was to make this lists or tuples, let's say, for example, I said list, right? Like it said. So the first one is a list, and this one is a list. But I want to make this one is a set. So list 1 plus list 2, right? Here's I want to say set. When I combine those two things together, list, sorry, what did I do wrong here? Oh yeah. Yeah. I don't have to do that. I'm doing that with numbers, but I can just do lists. Sorry, what am I doing? End of the day, tiredness. Okay, lists. Then I get green, brown, orange, red, purple, violet, blue, right? And if I was to do it again, I'm going to get green, purple, red, orange, brown, blue, violet. It's going to be random. It looks like it's random, right? But what it's going to do is combine all the elements. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible elements. But these ones would combine. So I only have one red. And then if there's any of the same, and then one green, one red, one green, right? And then it would be blue, purple, violet, orange, brown. Okay, that's how it does it. So combining two sets together, no problem. If you add set by itself, it makes the empty set. And you need to do this because it says you must use the set function with empty parentheses rather than the empty braces, because that makes a dictionary. So you can't do like, you know, colors, you know, or primary colors as an example. If I say like primary colors, you can't just do this, because that would make a dictionary, right? I would have to make that's equal to an empty set. Okay, that's what primary colors are, an empty set. And if I was going to print that out, print primary colors, then I would get a set type, an empty set. Okay. Frozen set is an immutable set. I'm not going to go there for now, but that's something that we can know about. Oh yeah, if I want to compare sets, so here's something. 135 is equal to 351 because it doesn't really matter the order. Sets are unordered. So it doesn't matter as long as the set contains the same elements as another one. And of course, because we wouldn't care about the order, then we would get a true back if one set is the same set. If it's a set of all colors that we have and it's the same colors, then it's the same, right? If we get not equals, if you try and compare something like this where it's clearly equal because they're the same elements just in different ordering, then you get a false back. Okay, so that's how that works. Okay, now this is where it gets really convoluted. When I first learned about this, I was like, whoa, a less than sign does not mean less than. A less than sign means something else. It's like, so the set to its left, right, as an example. So operator tests whether the set on its left side is a proper subset of the one to its right. So is this a subset of this? And the reason why, because they're equal, they're the exact same set, and they have the same number of elements, then this is false. Because 135 is not a subset of 351, but actually is the set of 351. It's exactly the same set. Whereas 135 is a subset of 7351 because it also includes 7. Right? So we have to make sure that they're not equal. So sets are not equal when we're looking at this, a less than sign. We also have the less than or equal sign. So this would be true, and so would this one. Right? So we can say that 13 is a subset of 351, and so we get that true because we're looking at less than or equal. Equal means it's either the same set or a subset. That's what it means. Okay? We can also use is subset, which is a method that's built into all sets. Is this one a subset of this other one? Right? The other way also works. So the greater than sign tests whether the left side is a proper superset of the one to the right. So is this one a superset of this one? No, they're the same set. Is this one a superset of this one? Well, yes, because this one is bigger than this one. It's greater than, that's what it means. And it contains elements from the left side, right? So it kind of made sense to me when I first said, okay, wherever the arrow is pointing, the open part of the arrow, the open part of the less than or greater than sign, it usually points to the superset. That's what it does. Okay, so if I go back a couple of steps here, and if I look at this, well, then the superset is on the right side. That's what this means. The superset must be on the right side, and then the subset is on the left side. And this one means the superset is on the left side, and the subset is on the right side. That's what this means. Okay, so just to not be confused. So why do we care about this? Why is this a big issue? Why does this help us? because when we're comparing different sets, and I want to make sure that, for example, the left side, in this case, has every color that the right side has plus more, then this is a great way of checking. Okay. Same thing with less greater than or equal sign. They could be the set of or a superset. That's what it basically says. It's kind of similar to that one. Okay, this is where they get a little weird. I want to create the union of two sets. Union of two sets. So this is the plus. Remember we had that plus thing happening, and I said, hey, I want to have this set plus this set together. So let's convert these back into sets as an example. So let's make this something that looks like this. So here's set number 1. Here's set number 2, right? And now I don't want to do this. I want to say that colors is equal to colors. Uh-oh. Uh-oh. No. I don't know why, but it's giving me this really weird. It's a what the? What? Sorry, I'm having a bit of technical difficulties, guys. In my selections. It's just probably. Yeah, look at that. It's caps. And I can't seem to turn caps off. What is locking caps for me? It's like caps lock and it's locked on. And I can't turn the caps lock off. I love it. Okay, what's happening here? There must be some kind of key I'm selecting, a key sequence. Bear with me while I deal with this technical difficulty. Right, well, let's see if I press one thing at a time. That's a pain. So it's this, and then I want to say plus union of colors 2. Let's just select it that way. Okay. We don't care. Oh, see, and I'm losing this flexibility again. It's almost like it messes my mouse up. It's some kind of input for sure. I'm gonna have to figure that out. Yeah, because I can't even. So what do I get when I get this? So union of this and this is kind of similar to what we did before. So I'm going to save and try it. And again, we get the same kind of idea where this is a union, right? So a union means take this set and take this set. And when I get back as a unique set that has only these elements, but no duplicates again, because sets don't allow duplicates. So that's what union does. I think it's a good operator. So that's the union intersection. We can use the AND operator instead of the union operator, right? So this means where the two sets are the same. So, 1, 3, 5 and 2, 3, 4. Well, the same element on both sets is just a 3, right? So if I was going to do that with this, oh yeah, I'm still caps. I'm still capped. Then this would be the union if I press the ampersand sign. So the 2 would create a union, and let's see what it would give us if we did it. Well, we'd have red, because red is where the two sets meet. I've got red in this set, and I've got red in this set. Well, then I'm going to have only red that's come back. That's the intersection. That's when the two things are the same. It's like drawing a Venn diagram. I always think of it like this, right? Where with set theory, as an example, I remember when I was learning it in school, just like you, I'm sure, I have some kind of set, and this could be the set of all boys wearing blue shirts, right? Set of all boys wearing blue shirts. You ever do this one? Okay, so this is that's that set. Okay, And then I make the set of all boys, as an example. Yeah, let's just do one of these. Wearing green shirts. Okay. So let's do another similar set size. Set of all boys wearing green shirts. Okay. Now, is there any intersection between these two sets? Well, the answer is no. There's no intersection between this set and this set. But if I was to instead of doing this, I specified that we have places where both sets intersect. Right. So let's say, for example, I was to draw this differently. See if I can erase this without playing too much. Yeah, okay, somehow I did that. And yeah, let's say, for example, I had try that again. I had another thing that looked like this. So again, Venn diagrams, right? And then if I had something like blue, and let's say I also included green in this diagram. And why is this important for data science? Because, my friends, and let's say red. Somehow I can fit red in here. I can't really fit red in here, but I will, right? How about that? Then we can say that this set on the left has blue and red in it, and this set on the right has green and red in it. From a union perspective, the resultant set would be blue, red, green. From a intersection perspective, the result would be red, because that is where the two sets meet. They both meet here. We're both there's only one element that they both have: union, intersection. Hopefully that makes sense to you. All right, so that is intersection. Okay, and again, you can use the intersection method instead of the AND operator. I like the AND operator a lot. Makes sense. Difference. So, okay, so this is interesting. Whenever I think about Boolean algebra, which is kind of what this is in some ways, so 1, 3, 5, and 2, 3, 4, well, I have 1 and 5, and I remove. So how does this become 1 and 5 is what I'm saying here, right? So it says a set of consisting of the elements in the left operand that are not in the right operand. So I have 1, 3, 5, and 2, 3, 4. 3 gets subtracted from 3. 2 and 4 don't really matter. So we end up with 1 and 5. That's the difference, right, between the two. And the same thing goes with this one: 1, 3, 5, 7, and we have 2, 2, 3, 3, 4, 4. Well, we have 3 on this side, so the 3's eat this 3, and we're left with 1, 5, 7. That's the difference. And there's a caret operator, this little caret here, which is the symmetric difference. So symmetric difference is there are elements of both sets that are not common with one another. So 1, 3, 5 and 2, 3, 4, we're left with 1, 5, 2, 4 in no particular order. 1, 5, 2, 4. Right, that's what the output would be. So you don't include the ones that are common, the symmetric difference. And you're going to say, Tom, I have no idea what you're giving us this for. It's for data science, guys. A lot of the stuff that we're showing here is all going to help you. This is what Python is all about. Not that Python was developed for data science, but it was developed for scientists. And so what they did was they built a set of tools for themselves, functions that would return quick hit kind of answers back to them. They know this stuff. If I want to get the symmetric difference between two things, so if I'm categorizing, if I'm saying, okay, I'm using some kind of facial recognition program, and I'm categorizing all the eyebrows that I'm seeing. Here's all the eyebrows that I'm seeing in a field of people, right? I only care about the eyebrows and their shape, right? Well, then I'm looking at the set of all eyebrows, and maybe I'm looking at the set of all eyebrows that have a peak, some kind of like, a pointed, kind of a pointy eyebrow as opposed to a rounded eyebrow, right? Well, again, you can use this kind of stuff, although I probably would use something more powerful like pandas or NumPy, right, to do that categorization. Disjoint. If they do not have any common elements, they're considered disjoint. So you can check to see if one set is disjoint with another. So they're disjoint means that they're separate. All right. So again, going back to our little drawing, then when we draw two sets, I have a set that's over here. All right. I have this set over here, and I have another set that's over here. They're not connected, then they would be disjoint. There's no intersection, and there's no union possible with these two sets. Okay. We can use the equal sign. So here we're making a new set, all right? And this pipe equals, right? Pipe equals is saying, okay, I want to take 135 and I want to add 234 to it. But I'm only going to get back a unique set that doesn't include 2 3s. It's like the plus equals when I looked at this. A union element, right, with an assignment element together. It's like a shortcut that basically says take these two, add them together, and then only get back what we have. So in other words, going back to our example in Python, instead of it doing, if I want these two to be together, oh yeah, I'm still having that problem. Then what I want is the pipe equals sign. Pipe equals, right? So let's say, for example, I want to add these two sets together. I'm trying to figure out a way of showing it this way. Let's suppose that this is colors, and this is colors 2, and I want to add colors to colors 2. Let's see if I can do this with shifting. Yes, colors is plus equals to colors 2. I'm just going to deal with my issue. Okay, I'm dealing with my issue. And there we go. We have the same kind of idea where you can kind of add these two things together, and it's a shortcut to add these two sets. So that's kind of interesting. Did I take off my thing? I did. I think every time I press that, I think it's me. When I press the command and pressing the left mouse button at the same time with the, oh yeah, definitely messing the keyboard up if I do that. Sorry, I'll figure it out later. I'll find out what the problem is. Anyways, so yeah, that's that one. Okay, update. It performs a union, so that's interesting. So if I do update, so if I say numbers.update and I update it with 10 more, I get a union of this, right? Modifying the original set, right, as an example. So I have the original set. Let's say the original set was called numbers or colors, and I want to do a union. That can something that I can do. Other things that I can do are and equals. This is a shortcut for intersection, an augmented intersection. Here is this actually should be minus equals, right, for an augmented assignment and difference assignment, and then a symmetric difference is this. Okay, so this is kind of a way of doing all these different things. There's also their corresponding methods: intersection update, a difference update, and a symmetric difference update. You can use all of these things to create different structures. All you're doing is you're mutating the original set, with whatever you're adding it into the other one. Okay. Okay, I want to add elements to the set. I can use the add method, but again, remember it's added in no particular order. So if I was going to go back to this, and if I said, okay, print colors, and then if I said something like colors, dot add, and then inside the colors, I want to add in a another kind of color, like let's say gray. It's not really a color, but let's say I want gray to be equal a color. Sorry for my typing. And then I want to print out the colors again. Print colors. There's a way around it. Always a way. But don't know why is it plaguing me like this? I have no idea. Darth Plagueis. Okay. Oh, you gotta be joking. Okay, there we go. That was weird. Yeah, so you can see that I've added gray, and it's added it in no particular order. If I do it again, you can see gray is added as the fourth element, as an example, right? So you can add elements with this, and I can remove elements, but it's going to remove, which is interesting, it's going to remove an argument, but it doesn't know. Okay, as an example, it's going to remove 3 if it exists. If it doesn't exist, right, then it'll throw up a key error. All right, so again, if I go back to this, I want to get rid of red. Colors dot remove, and then inside there, red. I want to remove red, and then I want to print colors again. So print colors. See, I'm using the, thank God for VS Code's code hinting capability. I can get by using the code hinting more than anything else. There we go. So violet, brown, green, purple, gray, orange, blue, but you can see now there's no red. We've removed red from that bunch, and if red didn't exist, if I let's say try doing this again, I would get a key error, unless I wanted to use the discard method. If I use the discard method instead of remove, then it wouldn't care if it existed or not, and it would do the exact same thing, discard. Okay, so it doesn't check to see that it's there. Okay. So that is removal. Pop is interesting because, again, it's unordered, so it's going to pop something. Now, popping usually means you're popping it off a stack, but there is no stack. Popping will work, but you're going to get a random value back. And if the set is empty, you'll get a key error. Clear removes everything from the set. And one thing that we want to talk about before we move on, I'm not going to do this part. I'm going to wait for next day to do that because it's going to be a longer, more than an hour to get through, is this idea of comprehensions, right? So we kind of did this last time where I had, this is the comprehension right here, this long curly brace thing. And a comprehension to me is almost like a lambda expression in some ways, okay? So it kind of goes like this. For every item in numbers, that's one of these, right? If the item can be divided by 2 and produces a remainder of 0, right? If item modulus 2 is equal to 0, then return that item. Okay? So that's kind of what it does. And then it returns a set of all items, right? Because the curly brace, we take the item, which is originally a list. We have a non-unique list with 1, 2, 2, 3, 4, and so on. And we want all even members, or even the population of items that are in the list, elements that are unique and even. That's what we want when we put curly braces around here. Okay. It's the last example we'll do, and then we'll stop for today. We'll make it a little bit early today. So if I did a comprehension on red, right, as an example, but it's hard for me to do for every color in colors, and then for every where the color is got a length of. I could try that. Let's try that. So, but I want to do a comprehension with some kind of list, just to be on the same side. So let's say, for example, we have a list, and the list is called fancy colors. Come on. This I'm not going to be able to get by. Fancy colors. And then say the list, we'll make it a list. So we'll say that some fancy colors like Snow White. Snow White. Oh God, this is terrible. And gunmetal. Oh, I'm suffering, right? Okay, one more. Can anyone suggest a color before I go crazy? Burnt orange. Okay, I'll do one. Burnt orange. Okay, so Snow White, gunmetal, burnt orange. Fancy colors, right? And I want to do a comprehension. So comprehension, it uses kind of like a different kind of syntax. So you can see that I want to return something, right? I want to return an item that has a specific length, let's say, right? So I can say that, you know, shortest. So I want to find the shortest one, right? Or we'll call it short, not shortest. Short is equal to, for every item, I want to return, this is the thing I want to return, my item. Okay. And just like it says here, for item in. And instead of color, we'll say instead of item, we'll say color. Come on. Bear with me, guys, while I kill myself. For, come on, for color in fancy colors. Right? If length of color, right, is less than 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, less than 9, right? Then return the color. So if that's right, I think I have it. So this is short, and let's print it. Oh, short. Okay, does that make sense? So color is the thing I'm returning. For in is a loop. If is my condition that I'm checking. So this is my condition. I'm checking to see if the length of the color, not sure if that'll work, is less than 9. If it is, then I'm going to return it. I should only return gunmetal. Let's see if that's true. No, I don't return anything actually. So why? Because probably short does not give me any value, right? Because of the length. Maybe we can just check to see if it's equal to. If, oh God, come on. Color is exactly equal to gunmetal. Oh, no. God. Oh, this is bad, man. So if it's exactly equal to gunmetal, then return it. Let's see if that works, and hopefully that will. Yes. All right, so it only returns gunmetal. So it kind of goes through. Yeah, bubblegum pink. I like that, Tiago. Next time I'll use it. But does that make sense? So basically, a comprehension is a quick way of doing a loop and a test. It's almost like I'm saying, hey, for every color that's in the colors in this list or in this collection that matches this condition, the condition to be on the right, then return it inside of color, right? And then whatever that is, make that into a, in this particular case, a set that returns a unique value, right? So again, if I was to say something else, let's say another gunmetal or something like that, it would only return a list that had only one in it, right? Or if I said something like, let's make it more interesting, not equal to gunmetal, then we should get a list that has the other two in there. Let's see. Yeah, burnt orange and snow white, right? So it says don't return a list that has gunmetal. I want to avoid that list, but go through the fancy list of colors and return only the ones that don't include gunmetal. Comprehension. Okay. And if I had it as if I made it instead of a list, how about if I made it into a tuple? Can I do that instead? So let's see what that does. And it returns snow white and burnt orange. Did I not save it? I did not. Then it returns something else. It returns an object. It says generator object sets, right? Where it's trying to return a set. If I try to make this square brackets, so I'm going to show you the difference. And if I set save and do the same thing, you see that I have the list that has snow white and burnt orange. So it does the same interaction for a list as it would for a set. But if I had more than one, like let's say for example in here, inside this list, I had another one that was burnt orange, or let's say it's just snow white because it's less painful for me. Snow white, right? So I had two snow whites and no dwarves. Two snow whites and a burnt orange and a gunmetal, right? As an example, in the list formation, I would get both back, right? So snow white, I get both those back. But in a set formation, set structure, I'm only going to get a unique snow white back, which is a difference. So that's the way that it would work for you. First one worked for you? Awesome. Didn't work for me. All right. Like the round brackets work for you? They didn't work for me. All right. All right. Anyone, any questions around this? So this is kind of cool. I'm going to put this up on GitHub. We're going to add to it because remember on Thursday we're going to do that visualization stuff that I want to do with you guys. It's more interesting than this. This is kind of understanding sets. So we would have finished off most of our collections with this one. The most common collections that you're going to see in Python. So to do this again, I'm going to say, oh gosh. Oh, I know what I'm going to say. I'm going to say goodbye. That's what I'm going to say. Just a moment while I shut down everything and restart everything. So save, goodbye, power off, power off, power off, goodbye. And hopefully, let's look at a Word document for a second where I can type regular stuff. Oh yeah, look at that. It's like I'm totally locked. That was weird, man. Let's get back in there and try and do it again. So my VM starts pretty quick. I'm not really that concerned about it, but I don't know what causes it. I think it's some kind of key sequence that I use when I do command. I'm trying to do an alt tab out of my VM, and I think it's messing me up. Yes. All right, let's try it again now while we go back in for a second. We'll put this on GitHub. So GitHub. One question I always had is a couple questions I got for the assignment before I stop for the day is so the assignment, do I have to do it in Linux? Well, yeah, you got to do it in Linux. Some people do not want to do their assignment in Linux, or for whatever reason. I'm not sure why, but you should be used to Linux by now. We've been using Linux this whole time. If it's difficult to record stuff with Linux, that's a different story, but Let's do a git init, git add dot, git commit -m, initial commit. Okay, we don't have a repository, which we'll make. We'll go to GitHub, and we'll go to Centennial, and we'll make a new repository. We'll call this repository, that will be public. I remembered it twice today. That was good. COMP301 in the summer 2020 semester, and it's lesson 10. Lesson 10. Come on. Tools, don't fail me now. And then grab these, this 2 pieces of code and go to here and right click and paste it. And that should do what I need to do. So you should have all this stuff. I mean, again, it's just an example of sets. I only wanted to talk about this because, again, we're like, guys, we're so ahead, and I want to make sure that you guys understand what we're doing. So I'm going slow on this stuff because some of this stuff can be very challenging. All right, so looking ahead, for those people who are not able to make things work last day, please be aware that as we get into this part, this data science dynamic visualizations, you can see that we're 30 pages in, and then we're going to get into this. This is a more complex section, and it talks about different things. But one thing that that you need to know how to use is matplotlib as well as Seaborn. So if somehow or another you were not able to get that installed last week, please make sure for Thursday you have matplotlib and Seaborn installed. Otherwise, the things we're going to be showing you on Thursday won't work for you, and it'd be pretty frustrating to watch me make a chart when you can't. Okay. I'm also going to include my source code on Thursday because some of the PowerPoint got cut off for some reason. So if you notice some of the source code near the end, which is here, it got cut off. Not sure why it happened, but I will give you the code as it is. So you can't, this is the one part that's not complete if you were going to try and do this on your own. So bear with me. On Thursday I'll have that completed code. I know what it is. It's just been cut off. Okay, so this, I'll let you know about that. All right, any questions around sets and with Python? And any questions in general, like any questions or concerns about Python? How are you feeling about Python? Are you feeling more comfortable with it now that we've been using it for several weeks, I would say? Because we're sitting at week 10. We've been kind of using it since week 8, 9, 10, you know, and a bit of 7. You guys feeling more comfortable with Python? Are you feeling still a weird, uncomfortable feeling with it? Is it really annoying, you know, or do you like it? More easy than Unix? Absolutely. I think Linux is definitely more challenging, but the thing about Linux in general, if I was going to generalize, is the more you use it, like we're in Linux environment with our VM, right? The more we use it, the more comfortable it becomes, and the less it's an irritant, right? I think if we were going to go and use Linux for the first time and try and operate in a Linux environment, you know, I think it would make anyone uncomfortable. Or, for example, if I said, let's not use Windows, let's use Mac. Some people would be very uncomfortable using a Mac, right, because of the way the operating system works. Yeah, I don't know about most. I think one thing that Tiago, that Python has that is logical and yet frustrating for some is the fact that there's not 2 billion brackets, that's for sure. But it's also, in the original way, when Python first came out, I'll tell you that one of the annoying things was that people couldn't use curly braces. They were like, wait, where's my curly braces? Where's my semicolons? You know, where's all this stuff, right? And I think that's something that, you know, that it was, you know, that was annoying to some programmers that were used to C-style language, right? Yeah, and I agree with you, Joseph. I think that, remember, it was made for scientists. It was made for engineers. It wasn't made necessarily as a programming language, although it's become it's one of the most popular programming languages in the world now, especially because of machine learning and all of its applications. So I think these are really good things about Python. So I'm glad that you guys are feeling a little bit more comfortable with it. And I think it's going to get it's going to get more comfortable as we use it. Again, I wish you guys had another course on Python. I'm not sure that you guys do have another course on Python for a while, if you have it at all. But I know that if you guys continue using a language like Python, one of the great things is, how do I mix and match? Remember that I want to tell you this, that if I'm creating a solution, right, you're going to choose the language and the platform that makes the most sense. In your mind, you shouldn't have a preference. It shouldn't be C# all the time, or Java all the time, or C++ all the time, or Swift, or name that language, whatever it is. It should be whatever language is required for that application. That's what it should be for you guys. And it should be the same thing for platform. It shouldn't matter whether you're on a Windows machine or a Mac or a Linux box. It shouldn't matter. You're going to use the best platform to solve your problem, whatever that problem is you're trying to solve. So hopefully I'll leave you with those thoughts. But that's my take on it. And you should try your best to also leave things like frameworks behind. You know, things like, well, I love this framework, and some people are stuck using the same framework over and over again because they love it or they know it so well. You know, but it's not necessarily what you know, but the best thing for the job. It's the best tools for the job. You know, you're not going to keep using an old tool that doesn't work anymore for the job you're trying to do. You're going to get a new one, right? So, and new tools come out all the time. So that's why one big challenge for us as programmers and developers in general is we have to continuously keep on top of things and keep our tools up to date. Anyways, that's it for me, guys. Thank you so much for coming on board today. I will see you guys on Thursday. And it's just a brief reminder again that next Monday, thanks for coming out for reminding me, is going to be a day that we're not going to have any class. Okay, guys, thank you so much. I'll stop recording now, and I'll see you guys on Thursday. Take care.